You probably remember seeing a certain formula back in math class, but what you probably haven't heard is its incredible story, one that spans empires, revolutions, and 4,000 years of human history.
Ah yes, there it is, the quadratic formula. For a lot of us, this thing was a monster from algebra class, right? Just a jumble of letters and symbols that our teacher told us, hey, just memorize this.
So, where did it come from? Well, here's the thing. It wasn't just discovered. It was invented, built piece by painstaking piece over millennia, with different cultures adding their own crucial parts to the puzzle.
Okay, so let's get into it. And to really understand this story, we have to travel way, way back in time, long before formulas, or even the number 0 existed the way we think of them today.
Our journey kicks off around 1700 BCE in ancient Babylon. And they weren't thinking about abstract equations. No, they were trying to solve a very real, very practical problem.
So on clay tablets just like this one, scribes were wrestling with a super common question. If you know the area of a rectangular field, and you know its perimeter, how can you figure out the exact length and width? I mean, this was essential stuff for farming, for construction, you name it.
And what's so fascinating is that the Babylonians didn't have a concept of a general formula. They couldn't just plug numbers into an equation. Instead, what they had was more like a recipe, a very precise step-by-step procedure that gave them the right answer every single time. So for a field with an area of 600 and a half perimeter of 50, they'd follow these exact steps. It's this beautiful, elegant process that tells them the length is 30 and the width is 20. And the amazing part? They did all of this without ever writing down a variable like x.
Okay, buckle up, because now we're going to jump forward more than 2,000 years. We're heading to the Islamic Golden Age, and this is where we see the huge leap from just following recipes to creating general rules.
So, in the 7th century, the brilliant Indian mathematician Brahmagupta writes down the first known general solution. But look at this. It's not an equation. It's an entire paragraph of instructions. I mean, it worked, but wow, was it cumbersome.
Then, in the 9th century, the Persian mathematician Al-Khwarizmi enters the story. He's working in Baghdad's legendary House of Wisdom, and he does something absolutely revolutionary. He starts to systematically classify and solve these kinds of problems, creating a whole framework for them.
And get this, he was so influential that the word algebra actually comes from the title of his groundbreaking book. His work was so foundational that today he's known as the father of algebra.
As if that wasn't enough, the word algorithm, that core idea of a set of rules, is just a Latin version of his name, Al-Khwarizmi. His legacy is literally embedded in the language of math and computer science. It's incredible.
So things are really moving along. But even with all these amazing advances, there was still a huge roadblock. Math was still being done almost entirely in words. To get to the formula that we recognize today, one final revolution had to happen.
This is the key, the massive shift from rhetorical, word-based math to the symbolic math we all use. I mean, just try to imagine solving complex physics problems by writing out long paragraphs instead of neat equations. That's the barrier they were up against.
And the person who finally smashed through that barrier was a French mathematician named François Viète, who lived in the late 16th century. What's wild is he wasn't even a professional mathematician. He was a lawyer who did math on the side. But his idea? It changed everything.
Viète's big breakthrough was to basically invent a new language for math. He started using letters to stand in for numbers, a simple but brilliant system. He used vowels for the unknown values you're trying to find and consonants for the known values. This finally allowed mathematicians to stop talking about one specific problem and start talking about all problems of a certain type at once.
And his goal was nothing short of breathtaking. He called his new method the analytical art, and he truly believed it was powerful enough, and I quote, to leave no problem unsolved. He wasn't just solving equations. He thought he was creating a universal key.
So, with Viète's new symbolic language, all the pieces were finally on the table, and the modern quadratic formula could take shape. But here's the twist. Solving this ancient problem, that wasn't the end of the story. No, it was the explosive beginning of a whole new chapter for mathematics.
See, the second mathematicians had this neat, tidy formula for second-degree equations, you know exactly what they asked next, right? They immediately went, okay, cool. What about a formula for third-degree equations, or fourth degree? How about fifth? The hunt was on.
And they did it. They found formulas for cubic and quartic equations.
But the quintic, the fifth-degree equation, that one stumped the greatest minds for centuries. And when the answer finally came, it was a total shock. It's impossible. There is no general formula for quintic equations using just basic arithmetic and roots.
And the mind-blowing reason why it's impossible came from this young man, Évariste Galois. He was a French political radical and an absolute mathematical genius who would completely change the course of algebra.
Tragically, Galois' story is as short as it is brilliant. The night before he was set to fight a fatal duel, convinced he was going to die, he stayed up all night, frantically scribbling down his revolutionary ideas in a letter to a friend. He was killed the next day, at just 20 years old, leaving behind work that would transform mathematics forever.
This incredible 4,000-year journey, from Babylonian fields to a tragic duel in Paris, it just shows you something amazing, doesn't it? The answer to one question often unlocks entirely new, deeper questions we didn't even know we could ask. And that process, well, that's what continues to drive science and math forward, turning today's solutions into tomorrow's profound mysteries.